Hey folks, in this video I want to start talking through one example of an ADT. So we're going to start with just one, and there are actually additional references if you look at it in the course textbook, but for now we're going to focus on one. Basically we want to take a look at this idea of how do I make something very well encapsulated as well as something that's immutable. So let's take a look. What we're going to be working with right now is something called Point2D. So Point2D is, obviously you can imagine, a very simple class. It's meant for representing a point on a plane. So let's just take a look, I guess, first at the API. Right? It's always nice to know before you use something what is available, how is it supposed to work. So we have our API over here. Now our API consists basically of a way to create an object, right, of this ADT, right, which is this up here, which is really just a constructor in Java, and then all the different methods, right, that are available once we have that object, right. So we have a bunch of things here. So let's just go top to bottom. So first, in terms of the constructor, we have two arguments, x and y. Well, that makes sense, right? If I'm building a point, right, I need the inputs, right, for the 2 points. All right, looks good. Then we have, right, basically a bunch of accessors, right? So we're going to extract information from this type. So I have x and I have y. That's pretty straightforward and obvious, okay? Just pulling out data. Now, over here, we get to something a little bit different, which is r and theta. And so here's kind of an interesting observation. I am basically able to manipulate this point in terms of its xy Cartesian coordinates or in terms of its polar coordinates. Okay, so I have kind of two options here. And from me, the user of this ADT, I shouldn't have to care. Remember that the idea is that for a true ADT, it's this black box where the internal representation is hidden. I have no idea, right, how data is being represented inside there. Okay, all I know is that this is what I can get out of it, right, x and y or r and theta. Last thing I have is distance 2, which is going to be another thing for extracting information. This here, right, is basically doing a computation between, I have a Point2D I'm holding on to, right, and I have another one. What's the distance between them? So yeah, these are different methods we have to work with. Note that this bottom part is sort of analogous to an interface in Java. And we will talk about interfaces later on, just for a little bit. Interface is basically like a list of methods that a class must implement. However, this is a little bit more than just an interface in Java because it also contains a constructor, a way to build it. Normally, interfaces in Java lack this sort of construction method, right? This way that you create something, right? A constructor doesn't exist. Only full classes have constructors. All right, but we'll come back to talking about interfaces a little bit while later. So yeah, we have again our main method, right? We're always starting here, right? The simplest possible code sample we could give. So let's just take a look through and see what's going on. So the first line, right, is basically creating a new P1 variable, right? So it's P1, we're creating a new point, setting its values as 3 and 5, right? So it's like, okay, I have a new point. And then I have point 2, same thing, I'm building a new point, 3 and 5. Note that if we were to draw those little diagrams we had in the previous slides, which are actually called box and arrow notation, it would look like this, right? We basically have 2 points, right? So this is P2, P1, and there are basically 2 objects out there which actually have the same stuff inside of them, but they are really different objects because we use the new keyword twice. So yeah, my P2 variable stores a reference to that, my P1 variable stores a reference to that. So that's how it looks kind of from the memory's perspective. All right, so looking down the rest of my code, I have basically my P1 dot equals P2, right? So I'm doing an equality check here. I want to know, are they the same or not? If they are, then I'll print a message to indicate it. Or if they're not, right, then I'll print the distance between them. So here, right, we have a few things being used. So here's equals. Notice the equals does not exist over here in my list of methods that I had, talked about. Why not? Well, it's not there because it's kind of a given, right? That was one of those common methods that Java always has classes support. So presumably when somebody did go and basically implement Point2D, it was up to them basically to implement a proper, override of equals that would check to make sure that x and y, right, or r and theta are the same thing, right? So that works out properly. Here we're just kind of assuming that that has been done behind the scenes. It's the best practice, so it's a safe assumption. All right. Then we have kind of just demoing a couple of things, right? We print out basically the x value on P1 and theta value on P2. So yeah, very, very simple example. If we were to run this code, right, it should basically give us, let's see, it'll give us distance, distance is 0, will be the first thing it gives us, and then it should give us basically, our x of P1, which is going to be 3 here. Then it'll give us the theta of P2, and I don't remember what the theta is. So it's something, it's something times something anti-something, I don't know. I don't remember my trig. So yeah, plus some other value here. But yeah, that'll be our output. All right. So there's a couple questions here on the bottom to discuss. So let's go ahead and read through the first one. Doesn't matter how Point2D is implemented. Okay, so this is a question for you guys. Take a minute, pause the video, think about it. So yes, right, it does matter, right? And it actually goes back to kind of our initial discussion on ADTs, right? There was one thing, right, that we had to deal with, which is performance, right? I don't really know how well things perform inside. Other than that, right, in terms of this being a black box, it'll always be fine. It'll always be fine. Probably for something that's as simple as a Point2D class, I mean, your performance is probably going to be, O of 1, right? Something really, really simple, really, really nice, pretty much no matter what the implementation is. But to be absolutely certain we are doing the right thing, we do have to kind of think in terms of performance is something that's maybe a little bit hidden here. What would make me a lot more happy with this is if it said something like this: O of 1, O of 1, O of 1, right, throughout the documentation to indicate to me that everything was fine. All right. So, okay, jumping on the next question. How might Point2D represent data? So, what do you guys think? Take a minute, pause the video. So there's two ways we could actually represent data here, right? We could represent it actually as X and Y. So this is our first choice. Or we can represent it as R plus theta. Okay, we actually have two choices here. Now, looking at this, we can't tell, right? I can't tell from this interface, right, or this API here, what is the internal representation, right? Is it X and Y, is it R and theta? Both those are valid options, but from my point of view right now, that stuff is hidden from me. I have no knowledge, right? It's basically would be fair game for the implementer of this API to use either method. So this, right, is hopefully, right, a properly structured ADT because of that, right? Basically, I have multiple choices for implementing inside, and it simply is invisible to me, right? This is a very, very generic interface, right? It doesn't matter if I'm picking one of those two types, it's gonna work out either way, right? And it's gonna work transparently to me, the user of this API. So how would I go about, though, choosing which method to use, right? Do I wanna use X and Y or R and theta? So this is actually an interesting idea here. What we wanna do is basically align our choice of internal data with how we expect it to be used. So let's say I expect this thing to be used, to access X and Y all the time. Well, in that case, I should probably have X and Y as my internal implementation because that'll be very fast to just do things like return X, return Y, right? Very straightforward. Versus if I had it stored as R and theta, right? Now I was using X and Y a lot, well, then there'd always be this conversion step where I need to do some trig and some calculations in order to get, right, R and theta from the internal representation of X and Y. So typically what we want to do is we want to make our internal representation basically, our internal representation should be like the most common way that thing is used, or the most common way it's accessed, right? So if it's most commonly, they're using X and Y like we have here in this example, well, then I should use X and Y in my internal representation. Really, right, if we think about this conceptually, conceptually, right, it shouldn't really matter what we choose, but in terms of performance, right, that's when we want to make that optimization step of picking, what it is that this would typically be used as. Either way will work, right? Either representation, right? It'll be interchangeable. Nobody will be able to see the difference in behavior from outside, but you'll get a little bit of performance from picking the right one.